Hi guys, welcome back to our lesson. So we are still looking at the concept of introducing functions and their inverses. Now we're going to move on to exponential functions and try to look at what are their inverses. But before that, we're going to look at some very key concepts that we need to know before talking about an exponential function and its inverse, right? So firstly, what we need to look at is just to remind ourselves of what an exponential function is. This is a function of the form f of x is equals to ab to the x plus q, right? Where this a, the b, and the q are just constants of the graph. And then normally we know that this only has one asymptote, which is q. At times they don't write anything here by q. It simply means it's plus 0. So you will find that the graph cannot cross on the y-axis when that is the case. But we will see that with the graphs that we are going to try and draw. Now, we have what we call the logarithms that we need to remember, right? But this is actually a new concept that you only now learn it when you start talking about the inverse of an exponential function. With the concept of a logarithm, this is when you have log of b base a, right? So we normally call the a the base, b is the number, and then m is the exponent. So how you say this will be log of b base a is equal to m. And this is the same as, it's going to be base to the exponent is equals to the number, right? Now remember, my base is the a, my exponent is the m, and then my number is the b, right? So in simple terms, this will be a to the exponent of m is equals to b. But what you need to know about this is a must always be greater than 0, and also a must never be equals to 1, because you can't have a base of 1 for any number for that matter, right? Because 1 is just 1. Anything that you raise 1 to, it will forever be 1. So you can't say my base is 1. Then with logarithms as well, which we call logs, these were designed to solve for unknown exponents, right? Because at times you'll find that we don't know how to find the exponent that we are trying to find. And as a result, we then use what we call the logarithms to try and find those exponents. So just for example, if I have 2 to the exponent of a is equals to 8, I want to know what must I raise 2 to in order for it to give me 8. Now, on a calculator, just below the on button, you will see that there will be a log that's written log with 2 boxes, a big box and a small box like that. In the small box, that's where the base goes. And then in the big box, that's where the number goes, because it's the number that you are trying to convert to exponential form. So this will be log of 8 base 2, which will then give us 3. And why 3? It's because that's the number you must raise 2 to in order for it to give us the 8. Now, to try and look at this concept of the inverse now of an exponential function based on what we've just looked at, remember, you just still need to know it's all about interchanging x and y. That will not change. But now the new thing here will be we solve for y by applying the logarithms, right? So in simple terms, when I have an exponential function, its inverse will be a log. And then when I have logarithmic functions, the inverse will then be the exponential function. You see, so that's what we need to look at in terms of these particular graphs. Exponential graph gives you a log graph. A log graph gives you an exponential graph. It really just a vice versa thing. And remember, in order to find the inverses of these logarithmic functions, we use the following conversions, right? Now, if I have exponential, remember I said you get a log, right? So if I have x is equals to a to the exponent of y, Then this is my exponent, remember, which is what I start with, must be equals to the log of the base and then the number here. So my base is a and my number is x. Hence is y equal to log of x base a. Then from moving from a log to a exponential form, it will also be y is equals to a to the exponent of x. Just remember that it's all about interchanging first before you can apply these conversions that I've just given you now. Now let's try and apply this into an actual question and see how this goes. The first thing we want to do is to draw the graph of f, and this is f of x is equals to 2 to the exponent of x, right? You know, you just need to find the x-intercept if you can, and find the y-intercept also if you can, and then just plot them based on that. Now, to do this, remember you use a calculator. 2 to the exponent of minus 1 is just 1 over 2. I can just do it here for you. And then 2 to the exponent of 0 will be 1. 2 to the exponent of 1 will just be 2, right? And then if I want to join these, firstly, what do I know? I know that my y value can never be 0 here, right? But x can be 0. So it means this horizontal axis, it cannot cross that axis because this acts as our asymptote of the graph, right? This acts as the asymptote of the graph. Now, it is minus 1.5, which is somewhere here, and then it will be 0 and 1, which will be somewhere there. It will be 1 and 2, which will be somewhere there. And then if I join them, it will then give me a graph that looks like that. And then I draw my arrows at the end. So this will then look like that, right? So since we know that there are no values for x when y is 0, we then conclude that y is equals to 0 is the asymptote of the graph, asymptote of the graph, right? Remember I did show you in terms of when we were drawing the horizontal line and claiming that it is an asymptote. Now, we need to determine the inverse function of this graph. Remember, this is an exponential graph, right? It means the inverse of this will be a log graph. So, you firstly interchange your x and y, and when you want to interchange your x and y, you will need to introduce the log there, right? So you use the logarithms in order to make the y the subject of the formula. Remember, this is my number, this is my exponent, and this is my base. Base is not the y. Let me just point at the correct thing. This 2 will be our base, right? And just remember, the log is normally given by exponent is equals to the log of a number to a base, right? So in simple terms, this will be y is equals to log of a number which is x and then base 2, right? And that's what my inverse function will then be. So remember, the concept of logs is very close to the concept of inverses, and we need to make sure that we understand this, because mainly the inverse functions that we're going to look at have to do with exponential functions, although here we're going to look at a broader picture of inverse functions. Please stay tuned. I'll be back just now. I want us to take a quick break and freshen up a bit so that we can look at some more questions when we come back. I'll be back just now.